Today we're going to talk about descriptive statistics. Descriptive statistics is actually the first part of every project of data analysis we're going to do. What we have with descriptive statistics is actually like introducing or exhibition of the data set to start with and what we're going to do with it. In this video, what we're going to do, we're going to have several parts of the descriptive statistics parts. At first, we're going to discuss the generation of a new data set, a fictitious data set. All of it is randomized. The second part is going to be generating frequency tables, and then we're going to discuss the central and dispersion measures, and eventually we're going to discuss plots. We're going to show some plots. To make a long story short, effectively for each one of these parts we can have quite a bit of a session for each one of them, and for each part we can discuss various topics of each session. But we're gonna just scratch the surface today, so this is what we're gonna do. So to start with, we need to generate the data set. So we'll start with generation of vectors, and from that we're gonna work on the data set, the whole data set. So this is how it's done. To start with, we're going to generate cities, a bunch of 2,000 cities. They are New York, Los Angeles, London, Paris, and Berlin. Then we're going to generate the gender, indication of males and females. Then we're going to generate salaries, which is a continuous variable. We're going to do the same with age. We're going to do the same with education, where we have levels of education like high school, undergrad, graduate, doctor, and postdoc. And we're going to go get all of this and wrap the data set into a single data frame. So this is how the data frame looks like. It has 2,000 entries. You can see that the first entry is of a New York female, which is salary is almost 2,400. She's 57 years old, and she's graduate. And then we have two males from Paris. For the first one, the salary is 2,085. Then for the second one, the salary is 2,681, and so on and so forth. So this is the whole part of the data generation. Now we want to see the first frequency tables. We have various parts of the frequency tables. We're going to see some of it, just again to see how this should be done. Again, it has many versatile directions, but this is some. So to start with, we're going to see the whole distribution of cities. We see that we have, out of the 2,665 are from Berlin, 71 are from Los Angeles, 533 are from London, 209 are from New York, and 522 are from Paris. You can see the same thing with proportions. This is the proportions. And we can also see 2-on-2 frequency table. That is, for instance, the gender and the education of the data set we just created. So we have females and males. You can see that we have doctors. We have 240 female doctors, 163 male doctors. We have graduate, 283 female graduate, 202 male graduate, and so on and so forth. We can do the same thing with the proportions. We can see the same thing here. And now we want to have a bit of a more advanced frequency tables. It's a bit more of a pivot table in Excel. It shows several aspects of the data we're looking for. It's a bit different from pivot table. It has a different functionality, but we can learn from this quite a bit. So in this example, what we do is actually we're going to see the city, and for each city we're going to see the count, how many responses we have from each city. We have the mean of the age, we have the standard deviation of the age, we have the maximum value of the age and the minimum value of the age. So this is the first aspect that we have. We can also use both city and gender and practically do several further things. It's going to look like this. It's a bit longer because for every city, effectively, we have two genders. We can say that we have 386 responses from females in Berlin and 279 responses in Berlin from males. We can see mean the mean values of the age, the standard deviation, the maximum, and the minimum. You can see the same thing for Los Angeles, for London, New York, and Paris. And this is not a usual table because we've also added the knit functionality that actually gives this a bit of a more elegant look. Now we want to proceed for the second part of the central and dispersion tendency measures. So we'll start with just a simple mean of the salary. This is how it's done, just mean, and then the indication of the variable we're looking for. The same thing with standard deviation. And then we can work with a more advanced tool. It's called summarytools. It's a more advanced package with quite a few resources we're going to use. We'll work on the continuous parts of the data set. The first one, this will be the discr function, descriptive function. It actually shows very basic measures of the continuous variables within the data set. In our case, it's age and salary. We can see the mean of each one of them. We can see the standard deviations, the mean values, the minimum values, the first quartile, the median, the third quartile, max, mad, and so on and so forth. We can see the whole thing here. The second thing we're going to use is taken from, again, from summarytools. We actually don't need this because our already knows this is summarytools. Frac data actually shows indications about the discrete categorical variables within the data set. In our case, what we have the cities. We can see the distribution for Berlin, London, LA, and so on and so forth. We can see the distribution for the gender, and we can also see the distribution for the education variable. We can see that we have we can see the frequencies. We can see the percentage of valid frequencies. We can see the percentage of valid cumulative frequencies, and also the total and the percentage of the total cumulative. So this is this part, and now we're going to discuss the plots and graphs. So effectively, for the plots and graphs, we're going to use the ggplot package. The ggplot package is actually one of the most commonly used packages for plots, and it's very rich and it's very enabling, and it has many plies, and it can show many versatile information about almost anything within this part of the data set, within this part of the analysis. So we're going to start with a bar plot, a simple bar plot of each one of the cities. So this is how it's done. We can see that we have each one of the plots. We can add, of course, the title. We haven't added this one, but we can do that. The colors are very basic. We have an indication for fill and for colors, and we can see basically the distribution of each one of the cities. Now we're going to do something a bit more advanced. First, we're going to use a randomized function for the colors. We're going to randomize the colors here. So what we're going to do this. We're going to use call1 for color ramp palette. It's a color ramp palette function. It's going to generate several colors for us. So this is what we're going to do to start with, and then we're going to use that call1 function that we just created to generate a histogram of the age variable within this data set. So this is how it's done, and actually the values, the colors are completely randomized because it's grabbed from the call1 function, and in the call1 function we don't know actually what values are going to rise. We can do the same thing. We can run it again, and we're going to get something different, some different set of coloring, and we can keep on doing this until we find something suitable for our needs and what we want. So after this ggplot of the age distribution simple histogram, we can split the histogram based upon gender. For instance, we can do this, and then we're going to get a specific histogram for females and for males. You can also do this not by columns, but we can also do this by rows. We're going to get the same thing, only for rows. Here we can do the distribution of salary per city. Again, we're going to use the call1 function that we have just created. We're going to do it for a boxplot. This is the boxplot. The boxplot is rather simple, rather straightforward. We have a boxplot of the salary for each one of the cities. You can see that in Berlin, we can also see an indication of outliers. You can see the distribution for LA, for London, for New York, and for Paris. And then we can spice up a bit the boxplot plot. Actually, I'm going to add gender as well, so it's going to be like this. Basically, it's the same thing, only it's added. It's added with the element of the gender, so it's split by gender. And here we can do another thing. We can do a different thing and add the education part for each one of the cities. So this is how it's done. We can see it takes a bit more time, so this is why it's a bit more slow. But we can see the distribution in Berlin for each one of the education levels. Same thing for LA, same thing for London, same thing for New York, and same thing for Paris. So to make a long story short, effectively in this tutorial we saw several methods for each one of the parts of the descriptive statistics part of the project. It discusses frequency tables. We saw several ways to produce the frequency tables, several types of frequency tables. We saw how to produce the dispersion and central measures, and we also saw how to generate plots. Again, as mentioned before, this is just scratching the first layer of the surface. We can have much more for each one of these parts and have much more options and do it much more even this was a reach part, but still it can be even reached depending on the desire, depending on the needs of each one of the users of this. So this was basically how to run descriptive statistics using RStudio.